Assalamu alaikum and good evening. Today we are going to start with question number 21. The diagram shows the melting point of the 8 elements with consecutive atomic numbers. Which elements could be sodium? So, if you recall, if let's have a look at the periodic table for this. So, if there is a sodium, so if you look at the position of sodium, the very next element after the sodium is a magnesium. So obviously magnesium has a higher melting point than sodium. And before sodium, below sodium, there is a neon. Okay. So and if you see further before sodium, there is a neon, which is a gas. So it means if magnesium has a higher melting point and this is a sodium, then the element which is below, which is beneath sodium is a neon, and neon has even lower melting or boiling point than sodium, right? So this can be a sodium. So if you look over here, in such way, we will find C. Yes, very good, Jazlan. So C is the correct answer over here. D, B, and A is wrong, and C is the correct answer. Is this understandable to all of you? Okay. Now, question number 22. The boiling point of bromine, ICl, and IBr are given in the table. Okay. Which row explains why the boiling point of ICl is greater than bromine. So if you recall, ICl has a permanent dipole forces, and it has a induced dipole forces. Okay. Further, why the boiling point of IBr is greater than ICl, and it is due to the more number of electron because both have a permanent dipole. Yes, Mariam, what you are asking about which part? Yes, did you asking about the previous question, Mariam? Okay, let me explain again. Uh, 1 minute. Okay, so if you see, they ask you in this question which is sodium. So they have given you A, B, C, and D. If you look at the periodic table, this is sodium, and before sodium there is a neon. Neon is a gas, right? So it means that if neon is a gas and sodium is a solid, and after sodium we have a magnesium. So it means that magnesium has a higher melting point than sodium. Neon has a lower melting point than sodium, and sodium has the melting point between these two. Yes, now did you understand that its melting point is going to be lower than magnesium because magnesium has a more strong metallic bonds due to the because it has a more free number of electrons. But sodium's melting point must be higher than the element before it, which is neon, which is a gas. Is this clear, Miriam? So that's why it means that if we plot it, it could be like this. Now, did you understand? Okay. So that's why, see, in this position only, that the one which is below sodium, below this one has a lower melting point, and which is after this one that has a higher melting point. So that makes that C can be a sodium. Okay. So now question number 22. ICl has a stronger instantaneous dipole induced dipole. Okay. And we have seen that ICl has a permanent dipole forces. That's what we have decided. So if you see here, it is written for ICl, but here they are saying that it is has a stronger instantaneous dipole or induced dipole, which means that A goes wrong and C also goes wrong. So A and C cannot be the answers. And as we see that I have told you that it has a more number of electrons, which means that there is a stronger permanent dipole forces in it, right? So here in B, okay, yeah, that can be another important thing. But when we see chlorine, bromine, and iodine, right? So when iodine and bromine are bonded to each other, their electronegativity differences actually gets very low. So it means that between the IBR molecule, there must be a induced dipole forces in IBR. But these induced dipole forces are stronger. That's why its boiling point goes, higher than ICl. So for this reason, B goes wrong, and you are left with the B option. So B is the correct answer. Why we would say that it has an induced dipole forces? Because iodine and bromine are just on one each other. So their electronegativity difference is very smaller, which makes that they have an induced dipole forces. ICl have a permanent dipole forces, and bromine have a induced dipole forces. Okay. Now, question number 23. A solution containing both Mg2 positive and Sr2 positive at the same concentration. Okay. The solution is divided into two equal portions. Hydroxide is added dropwise to one portion, dilute sulfuric acid is added dropwise to the other portion. Okay. Precipitate seen first on sodium. Okay, if you recall, group 2 hydroxide solubility increases down the group, and group 2 sulfates solubility decreases down the group. That is the trend that we have studied in the group 2. Okay. So there is a magnesium and there is a strontium. If you find them in the periodic table, you will see barium, magnesium, calcium, strontium. So there is a magnesium hydroxide. On adding sodium hydroxide, it is formed, and on adding sodium hydroxide, strontium hydroxide is formed. So between these two, which one is more soluble, magnesium hydroxide or strontium hydroxide? Magnesium hydroxide is insoluble. So because it is above, so its precipitates forms first. So it means that between these two, the hydroxide solubility is decreasing, is increasing down the group. So a strontium hydroxide would not get dissolved. Strontium hydroxide gets dissolved and magnesium hydroxide's precipitates are formed, right? So in this way, we can see that these two are going to be the wrong one and we are left with the A and B. Now, magnesium sulfate forms and strontium sulfate form. So among these two, which one is less soluble, magnesium sulfate or strontium sulfate? Yes, which one is less soluble between magnesium sulfate and strontium sulfate? Strontium. Yes, magnesium sulfate is going to be more soluble and strontium sulfate is going to be less soluble. So precipitates with the sulfate, strontium sulfate will show the precipitates, not magnesium sulfate. So A goes wrong and B is the correct answer. Is this clear? Okay. Now question number 24. Structural isomerism and stereoisomerism. Now from here onwards, you are going to see the questions from organic. Should be considered when answering this question. Okay, you have to consider both type of isomerism. If a molecule contain two non-identical chiral carbon atoms, four optical isomers exist. How many are there with the molecular formula C7H14O and a 5-membered ring and a tertiary alcohol group? Okay, so we have to draw it and make it. Okay. So they have given you the molecular formula C7H14O, one thing. The second thing, it must have a 5-membered ring. Okay. So 5-membered ring. I have made 5 carbons. Okay. There is a one possibility that 6 and 7 carbon are here. And they have told you to make the alcohol group. A tertiary one. So alcohol group can be a tertiary one. If I put a OH over here, is this understandable? Then there is the second possibility. If I make the two carbons like this and put a OH group over here, then it can be another secondary alcohol with a 5-membered ring and a tertiary alcohol on it. So there are two right now, right? Now, beside this, if I put the other carbon side chain on a difference of a one carbon and then put a OH over here. So this is the third isomer, right? Then if I put the other carbon over here and keep the OH over here, this is the fourth isomer in which there is a five-membered carbon ring, molecular formula C7H14O, and a tertiary alcohol group. Okay. And there is one more possibility that if I put two carbon chains on a one carbon, okay, then I can't put a OH over here. I have to make the OH a tertiary. Tertiary alcohol group. So there are four. Can be like the first one. Okay, there is one more thing very important. These four, if you see, all of these four have a one chiral center. If you look closely, all of these four have a one chiral center, so it means they all are going to show their mirror image. So they all shows their, mirror images. So it means that right now, till right now, there are 8 isomers which exist, but they there is no eighth number over here. So I have to figure out one more which fulfill all these three conditions. Okay. Carbons over here. 1, 2, 1, 3, 1. And with a 5-membered ring. Okay. There is a it's a C7H14O, which means there must be a double bond over here. Otherwise, it can't. If I'm drawing like this, then these are basically C7H16O. So there is a one possibility, there is a double bond lies over here. Okay, in this case, the double bond is going to be present over here because on rest of the positions it can't be. In this case, the double bond is going to be present over here. and then double bond can be present on this position. Okay, so whenever that is the important thing over here that you need to know. Whenever you will find this kind of a question, leave it for the end because this kind of a question always takes time. So don't waste the time for 1 mark on such kind of a question where you have to find the maximum number of isomers. So the other possibility will be this one. So this can be either, out of these two are not, cannot be. Because this can show optical isomerism, this can show optical isomerism. This can be over here. Yeah. This can show optical isomerism. This one and this one. So either it can be out of these two. Okay, I will check and let you know because these kind of a question always, takes a plenty of time. So always leave these kind of a question where you have to find so many number of isomers at the end and do the rest of the questions. But I doubt about 13, I'm not sure, but let's see. Okay, so it is probably C is I think correct one and D is not because it has a, there are so many more number of isomers that you have to figure out. Okay, now question number 25. Which reagent will react with pentane 3-ol to give a mixture of stereoisomerisms? Okay, pentane 3-ol. So see 1, 2, 3, 4, 5, and over here we got the OH. Okay, with acidified potassium dichromate, if you see, it is going to convert it into a ketone, and ketone is a planar one, a carbon. In this reaction, this will going to form this, and in this way, it doesn't show you the stereoisomer, right? So A can be a wrong answer. With concentrated sulfuric acid. Yes, if we reacted with the concentrated sulfuric acid, the elimination reaction occurs, and as a result, we get this thing. And if it's a pent-2-ene, so this pent-2-ene can show cis and trans. So this is formed, so it can be cis and it can be a trans, right? So if it can be a cis and it can be a trans, so this can be a correct answer. Ethanoic acid in the presence of little sulfuric, concentrated sulfuric acid. Here it's an esterification reaction. And in esterification, there is no, a chiral center has been formed. So no stereoisomerism can be shown over there. And hydrogen chloride, if we reacted with the hydrogen chloride, only OH is displaced by HCl. As a result, no, optical isomer or sorry, no chiral center or a double bond can be formed. So D goes wrong as well. So B is the correct answer, where we are getting an alkene, and the alkene can show cis and trans. Okay, now question number 26. An organic molecule W contains 3 carbon atoms. It requires 4.5 molecules of oxygen for complete combustion. What could W be? Okay, So W has a 3 carbon atoms, and on combustion it needs 4 oxygen. Okay. So if it's a propane, for example, so it is going to be C3H8 reacting with oxygen, forming carbon dioxide and water, right? If I balance it, there are 3 carbon atoms, so I'm going to put 3, and there are 8 hydrogen atoms, so I'm going to put 4. So 3 times 2 makes it 6, and 4 times 1 makes it 4. So there are 10 oxygen atoms, so I need to put a 5 over here, and they are asking 4.5, so A goes wrong. Is this clear to all of you? Okay. Now propanoic acid is C2H5 CO2H. When it reacts with the oxygen, we again get carbon dioxide and water. So there are 3 carbon dioxide formed, 5 and 6, 6 hydrogens are there. So I will put 3 over here. 6 oxygens, 3 times 2 makes it 6, and 3 times 1 makes it 3. So there are 9. So 2 oxygens are already there. So if I remove 9 from, if I remove 2 from 9, I'm left with the 7. So 7 means 7 over 2, which makes it 3.5. So I need 3.5 moles of oxygen. So that's why B goes wrong as well. Okay. Now propanol. Propanol is C3H6O. So when I react with the oxygen, carbon dioxide is formed and water is formed. 3 carbon dioxide, 3 water. So 6 times 3, 3 times 2 makes it 6, and 3, which makes it 9 total oxygen, and 1 is there. So 8 is left, so I'm going to put 4. So I need 4 for propanol. So C goes wrong as well. So it means that if you are sure about the 3, so it means D can be a correct one. Let's have a look. It is going to be, it's an alcohol. So C3H8O. CO2 and water. So there are 3 carbons, 4 water. So 6 plus 4 makes it 10. 1 is over here. So 9 are left. So for 9, we are going to put 9 over 2, which makes it 4.5. So D is the correct answer. Is this clear to all of you? Now 27. Which equation represents a reaction that proceeds through initiation, propagation, and termination steps? We know that is a free radical substitution. And if you see over here, there is a free radical substitution. So it can be a correct answer. Here, bromine, it's a nucleophilic substitution, so it can be proceed through initiation, propagation, and termination. Yes, Hassan. Yes, can be a correct answer. C6H12 and H2O, it's an addition, so C goes wrong as well. Okay, aldehyde with HCN, it's a nucleophilic addition, so D goes wrong as well. So A is the correct answer. Okay. Now, question number 28. Okay. Structural isomerism and stereoisomerism should be considered when answering the question. A set of isomeric hydrocarbons contain 14.3%. It's hydrocarbon, which means carbon and hydrogen. All react with the bromine by addition. So it's give me a hint that there is a carbon-carbon double bond with 0.280 gram of each hydrocarbon reacting with 0.799 gram of bromine. What is the maximum number of isomeric compounds in the set? Okay, so we have to figure out the isomeric compounds, but we have to first figure out how many carbons were there. So if it's the percentage of hydrogen is 14.3, so the percentage of carbon is going to be 100 minus 14.3. Can anyone use the calculator and tell me the answer quickly? Eighty-six. 85.7. Okay. So now first find the empirical formula. I think which will help us to figure out, but there is one issue. $85.7 and 14.2 divided by 12 and divided by 1. Can anyone divide by 12 and tell me the answer, please? Yes, Jislan, Hassan, and Lima, thank you. Okay, 7.14. And here we are going to get 14.3. So 7.14 and 14.3. So it is going to be 1:2. Okay. So we got, okay, it's an alkene, C double bond C. Okay. So, okay, let's assume if it's C3H6 and it is reacting with 1 mole of a bromine. So if it's a C3H6, what would be its MR? 12 times 3 makes it 36, 36 plus 6, 42. Right? And over here, if you see bromine is 79.9, so can 79.9 times 2? 80, 80, 160, 159.8, right? So if the hydrocarbon has 0.280 mass, then what could be the value of X? Can anyone calculate the X over here? What can be the X? Okay, so X is 1.065, right? So it means that with this, we need this much mass of bromine, so it's not. So it can't be C3. Okay, let's work with C4. If it's C4H8 and we are reacting with the bromine, we know their mole ratio is 1:1. So C4 is 12 times 4 is 48. 48 plus 8 is 56. So 56 is reacting with 159.8 and 0.280 with X. Now, can anyone calculate the value of X? Yeah, I think now you are going to get 0.799. That's what I think. In this case, you are getting 0.799, isn't it? Yes. So see, so we got to know that the hydrocarbon has a molecular formula of C4H8. Now what they are saying that how many isomeric compounds of C4H8 can react. Okay. So let's have a look. One can be but1ene, one, right? Then it can be a branched structure like this and having a double bond. Second, then but2ene, and but2ene can be a cis and trans as well. There is no other possibility. So it means there are 4 structures, one but1ene, one 2-methyl prop1ene, and third one is cis but2ene and trans but2ene. So A, B, and D goes wrong, and C is the correct answer. Okay. Now question number 29. Which row describes the solvent used and type of a reaction occurring when bromoethane reacts with NaOH to form ethene? So if you recall, we use always C Bromoethane to ethene. So it means bromoethane is this, and it is turning into ethene. So it is which reaction? Elimination. So the one which here substitution is written goes wrong. And for this, we always need a ethanol, not water. So C goes wrong, and A is the correct answer. Yes, very good, Hassan. Now, question number 30. Which row describes the type of a reaction that occurs when propane one all reacts to form named carbon containing products? Okay, which row describes the type that reacts when propane one all reacts to form the named carbon containing product? Propane one all turns into one chloropropane, but that could be a substitution, not addition, right? So A goes wrong. Carbon monoxide, it's not complete combustion, it's incomplete combustion, so it can form carbon monoxide, so B goes wrong. It turns into propene, dehydration of propanol. Yeah, when we dehydrate it, when the elimination occurs, it's sorry, propene can be formed. Propanol is an aldehyde, and aldehyde formed by the reduction, by the oxidation of alcohol, not with the reduction. So D goes wrong as well. So C is your correct answer over here. A is the correct answer, because if you see bromoethane, which means this one turning into ethene, so it's an elimination. And for elimination, we use sodium hydroxide in ethanol, not in water, because when we use sodium hydroxide in a water, substitution occur. And instead of bromoethane, we got ethanol. From bromoethane, we got ethanol, not alkene. Okay. Okay. This one is question number 29. Now question number 31. Okay. Which statement describe what happens when 2-chloro-2-methyl propane is warmed with sodium hydroxide? So see, 2-chloro-2-methyl propane. So propane, 2-chloro and 2-methyl. So isn't it a tertiary? And if you recall, it's a tertiary, and it is reacting with aqueous sodium hydroxide. So obviously nucleophilic substitution occur, and it is going to be SN1, right? Not SN2. This secondary halogenoalkane. So first thing, it's completely wrong. It's not secondary. It's again secondary. This tertiary, yeah, does not react with hydroxide ion. Completely wrong. Reacts mostly by SN1 mechanism. That's what we have studied when there is a tertiary alkyl halide. So when it goes, yeah, P1 is hard, Happy. P1 is relatively very hard. So you have to practice a lot. And you have to manage the time as well. Now, question number 32. How many structurally isomeric secondary alcohols were there with the molecular formula C5H12O? So see, they are asking for the secondary alcohols. So 1, 2, 3, 4, 5 carbons. So propane 2-ol, 1, 2, 3, 4, 5 carbons. Propane 3-ol, 2. 1, 2, 3, 4, and I put a side chain and then OH. So propane 2-methyl butane, oh, sorry, 3-methyl butane 2-ol. And if I change the position, so that is the just the swapping of the position. Okay, so both are same. So, and if I keep 3 carbons, if I try to put both on the same carbon, which makes it tertiary, not secondary, right? So it can't be. So there are only 3 options. So A, B, and D goes wrong, and C is the correct answer over here. Now question number 33. Which reagent can confirm the presence of carbonyl group in an organic compound, does not distinguish it between aldehyde and ketone? So it's, I think everyone must just know that it is going to be B only. Okay, now which compound gives a positive test with the alkaline aqueous iodine and does not show optical isomerism, which means no chiral center. Okay, no chiral center. So if I look for the first one, CH3, C double bond O, and if it's showing aqueous alkaline iodine a positive test, so it means either it must have a this group or it must have a this group. Okay, so if you look at A is this thing. So if you see A has a this group and no chiral, right? So A might be our answer. If you look at this carbon, it's a chiral carbon. So it means it can show optical isomer, so B goes wrong. And if you see this carbon, it is also a chiral carbon. You can draw it open, draw displayed form, and you will find. So it's a chiral carbon, so it goes wrong. And if you see this carbon, it's not chiral. Okay. So if I draw this, let me show you guys this thing. So there is no chiral, but no positive test with alkaline aqueous iodine as well. So that's why D goes wrong as well. So A is the correct answer. Okay. Now, question number 35. Two samples of compound X were treated separately with the different reagents which were added in excess. The products of these two reactions are shown. Okay. With the reaction one, if you see that is an aldehyde converting into carboxylic acid, so it means it's an oxidation. And in reaction two, if you see all are turning into alcohols, this ketone and aldehyde turning into alcohol, so it means it's a reduction. So and both ketone and so for reaction 2 it's a reduction, so it means it can be NaBH4, right? Because that is the reducing agent. So that makes A and C goes wrong. Okay, now the interesting part, if you see this is the oxidation, but this ketone would not oxidize. But if you see alcohol does not oxidize, only aldehyde is oxidized. If I use so dichromate, we know that dichromate can oxidize both alcohol and aldehyde, right? And here alcohol is not oxidized, only aldehyde is oxidized. So that's why we can are sure that B cannot be used over here, because if B would be used, then alcohol is also oxidized. So B goes wrong as well. And it's a tolerance reagent, yeah, because it can only oxidize aldehyde. So D is the correct answer. Now question number 36. Which method could produce butanoic acid? An acid-base reaction involving this. This is a salt. And it can be, yeah, if we add HCl or any acid, it can displace the cation and turn into this. This is a butanoic acid. So this can be correct. Hydrolysis of this, if you see 1, 2, 3, 4, 5, there are 5 carbons. So pentanoic acid is formed on hydrolyzing this pentane nitrile. And they are asking you to for a reaction in which butanoic acid is formed, so B goes wrong. The acidic hydrolysis of this, okay, on hydrolysis it breaks into from this, so there are 3 carbons and there are 3 carbons, so propanoic acid is formed, so it goes wrong as well. And over here there are 3 carbons, so on oxidation of it we are going to get propanoic acid, not butanoic acid. So B, C and D goes wrong, and A is the correct answer. Okay. Now, question number 37. which ester may be hydrolyzed to produce two products, one of which may be reduced to the other? Okay. So it means that if one can be reduced to the other, so it can be, see, if we hydrolyze ester, we get acid and alcohol, right? And acid can be reduced to alcohol as well. So it is only possible that we are getting one product can be reduced to the other. Okay. So it is only possible when it's a symmetrical molecule. So if you see, if you hydrolyze this one, you are getting CH3, CH2, CO2H, and methanol. So if you reduce propanoic acid, you are not going to get methanol, you are going to get another product, not the same one. Okay, so A goes wrong. If you see over here, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, you see, if you hydrolyze this one, you are going to get CH3, CH, CH3, and COH, that is an acid. And if you see the alcohol, it is also CH3, CH, CH3, CH2OH. So see, if you reduce it, you are going to get this, that carboxylic acid is going to turn into the same alcohol. So that can be an answer. If you see, there are 3 carbons in the linear line and there is a branch one. So on hydrolysis, we are getting different products. So C cannot be an answer. And in D, if you see, there are 4 carbons over here and there are 3 carbons over here. So due to the different number of carbons, we are not going to get the same product. So D cannot be an answer as well. So B is the correct answer. Now question number 38. 2 compounds X and Y are mixed with a little concentrated sulfuric acid. Is that it? Okay. Ester Z is formed and the resulting mixture of the product. Okay, that is ester Z. Which 2 compounds could be X and Z? So just break from the ester bond. Okay. There is a one issue over here. Okay. If you break it, see, you are getting a carboxylic acid. Here you are getting a carboxylic acid. Right? So the carboxylic acid is the one which has a 2 carbons, right? So it means that these 2 are correct and these 2 are wrong. Now, if you see over here, the central part, it is like this. So this was the alcohol. So see how many OH groups it has? 3. And if you see over here, there is a 1 OH group, 2 OH group only. So C goes wrong. And if you see in D, there are 3 OH groups, right? So it can be a D. So over here, D is the correct answer. But there is a one issue still I didn't understand, that here the 2 carboxylic acids offer 2 carbon atoms and this one is offer 3 carbon atoms. Why is it so? Oh yeah, there is a one possibility as well, because they are saying 2 carbon atoms. Wait, there are 2 compounds, right? So it means that there is a possibility, because if I break it from here, I am getting the 3 carbon carboxylic acid. So it means that this was the compound. So if this was the compound, one compound, the X we have identified is a ethanoic acid. So if this was the compound, so this bonds remains the same. And over here we get OH and over here we got the OH. So see, one ester group and two alcohols group are there. So if you see, okay, if you see there is three OH groups in D, so D cannot be an answer because this is wrong. And if you see over here, there is a ester and two OH groups. So yes, C is the correct answer over here. Okay, now question number 39. The diagram shows a section of a polymer. Which monomer will produce this polymer? Okay. So isn't it, this is the repeat unit? So if this is the repeat unit, then it means if I see this thing, right now I am making the repeat unit. On both the sides there are, okay. So when these bonds are broken, they are going to form a double bond over here. But when you form a double bond over here, the carbon in the middle already had a single 5-4 bond. So this bond can be broken. So this can be the monomer. So if you see this monomer is a D. So D is the correct answer over here. Now question number 40. There are two naturally occurring isotopes of bromine. The one isotope has a 44 neutron and the other has a 46 neutron. Okay. Ignoring fragments, how many peaks are there in the mass spectrum of tribromomethane? Okay. So, okay, just add them. Okay. 44, 44, and 44. One possibility. Second possibility is 44, 44, 46. Just add them and tell me the values in the sequence. Okay. Then 44, 46, 46. And then 46, 46, 46. So these are the four possibilities, and I think on all of them I am going to get the different masses, right? 2 units plus 4 units plus. So these are the four possibilities of the 3 bromines. The rest of the 2 atoms are only 1 and 1. So it is going to be C over here. So C is going to be the correct answer. A, B, and D goes wrong. Is this clear to all of you? 130. Yeah, see, we are getting different. So here we have ended the paper. I think one question is left that you guys also have seen, that it is a very big question because due to the move, there are so many numbers of isomers in that. So if you find any question like that, just leave it initially and don't try to waste the time on it, and try to do it at the end. Okay. So tomorrow we are going to start, inshallah, new paper. So see you everyone in the next class. Okay. Take care. Goodbye and Allah Hafiz.